So good afternoon, ladies and gentlemen. I'm Bernard Freund. I work at the European Space Agency, a senior research coordinator. And I have been convening this space exploration event where we have brought a surprise for you. It will be a session on lunar and planetary missions, science and exploration. So we have some very prestigious speakers with us from the European Space Agencies, from NASA, and a number of also contributions from all over the world. But at the same time, we have the honor to host the giving of the first Curien Prize. And for this, I would like to call Dr. Colin Hicks and Professor Roger Bonnet to join us on the podium. So Dr. Colin Hicks is the president of EURISI that is working across Europe to bring benefits of using space to people outside the space sector. Until 2 years ago, Colin was Director General of the British National Space Centre. We have also with us Professor Roger Bonnet, former Director of Science at the European Space Agency and currently the Director of the International Space Science Institute and the President of COSPAR. Ladies and gentlemen, lunar and planetary explorers, please welcome them. So I'll give the word to Dr. Colin.
Thank you very much, Bernard, and I'm very grateful to Bernard and to the organizer of the conference for giving us the space to make this award. The Hubert Curien Award is given every 2 years to an individual or an organization that's made an outstanding contribution to peaceful uses of space and to international cooperation. This year, the award is going to be given to Roger Bonnet, who is on my left. Roger Bonnet needs no introduction to people in the space sector, and especially in the science and exploratory areas. Perhaps Hubert Curien does. Hubert Curien was a French politician in charge of research and development, an absolutely inspirational and charismatic man who is commemorated by this award. And what I know is that Hubert Curien will be looking down and smiling with pleasure today, because I know that Roger was one of the people that he admired, one of the people I'm sure that he mentored in the stages of Roger's career. It's my pleasure and privilege and honor to present the award to Roger Bonnet, and his name will be emblazoned on the award and will be remembered in that means, but he'll be remembered far more, of course, for what he actually did that has earned him the right to this award. Roger.
Just a brief words of acknowledgement and thanks to you, Colin, for this beautiful award, really. Thanks to EURISI to have presented it to me. It's a great honor. And it's great to receive an award named Hubert Curien, I must say. As you rightfully mentioned, he was a great man, a great humanist, certainly, a great promoter of international cooperation, and a great friend. International cooperation is intrinsic to space science and space research and an essential element in undertaking space science and space research missions. Looking up, stars do not belong to anybody. They are international. They belong to the scientists who are able to observe them and to the people who are amazed by the view. They are the patrimony of scientists and of humanity. Looking down, the borders among nations are not seen by our spacecraft. It's a unique opportunity to receive this award during this session on planetary exploration for the Moon, Mars, and other planets, because nobody would foresee such endeavors without international cooperation. I'm very grateful to the organizer of this session and to my dear friend Bernard Freund for having offered the opportunity for us to speak today. Thank you very much.
So it's an honor for me and a pleasure, as I had some affiliation with Roger Bonnet, as he's one of his PhD students. But it's also a moment where we can show the legacy from Professor Creuillat inspiration, from Professor Bonnet, and to the next generation of doers. And we have on stage Professor David Southwood, who is the director of the Scientific and Robotic Exploration Program of ESA. And we have Dr. John Connolly from NASA in the Constellation Office. And I would like to invite them to handshake towards the recipient of the Creuillat Prize of this year. So this is, I think, quite an emotional introduction for what will be our plenary event this afternoon. And so we'll have an event where we are going to discuss lunar and planetary robotic mission, mostly. And we'll have a series of presentations by Professor Southwood and by Dr. Connolly. And we try to have something very interactive. And I would like to start with join your stage, and we will have a presentation. Please, can we have the first slide? Yeah, so the context of this presentation is we have a very exciting times now for scientific discovery and exploration, fleets of orbiters, lander and rovers, and we will hear some update on upcoming missions from the various space agencies. This is relevant to activities that are conducted at the International Astronautical Congress in relation with IAF committees, with COSPAR, with International Academy of Astronautics. So it's a forum where we try to get also your input. And so please don't hesitate to ask questions. For this, we have some co-moderators here with me that can hand you some form where you could write down your questions all over this plenary session. We collect them and we try to give you the opportunity to ask and give you some answers. So with no further ado, I would like to invite the first speaker, Professor David Southwood, to present the views of ESA and his own views, I'm sure, on lunar and planetary mission. Thank you. Please welcome David Southwood.
Right, thank you very much, Bernard. I work for the European Space Agency. I don't know how many of you know what ESA stands for. It looks as if most of you think you know. Well, the S is obviously for science. The A is for applications, which our agency has to do as well as science. But the E is for exploration. I see exploration as fundamental in space, and it comes before science and applications. It's the chief element for me in space, and the results of exploration lead to science and applications. And it's very thoughtful of our agency to name itself ESA for that reason. If we'd used the French, the order of the letters would be wrong. So what does science and exploration mean for the person in the street? And I think it does mean exploration first, because you can express where we are in space exploration by two basic kinds of questions. One is physics, how did we get from the Big Bang to here and now? And the other is biology and chemistry, really, and I think amenable to understanding by just about anyone who's looked up at the night sky. Are there worlds elsewhere? Which carries with it the question of how did our world come to be, and could it happen elsewhere? This, of course, is real exploration. Two people on the moon, raising somebody's flag. I can't remember which one. It seems to have stripes on it, but that's not many flags have stripes on. That, for me, is a defining moment for space exploration. And I think today, though, we're going to talk about robotic exploration and its part, and whether one can make robotic exploration reflect the feelings many of us old enough to have lived through July 1969 felt when we saw people first on the moon. I think it is important to say that when you go to the moon, you're going partly for human reasons and partly for scientific reasons. And this is my lesson on that. A 19th century scientist, Charles Darwin, changed our universe by exploring with an explorer, namely Captain Fitzroy, a naval hydrographer whose job it was to map the oceans, map the depth of the oceans. He took along Charles Darwin as a scientist on his ship. Of course, the result was a total change in our view of the universe called the theory of evolution. The irony is, of course, that Fitzroy never accepted the theory of evolution, but without him there would have been no trip for Charles Darwin to the Galapagos and no change in the universe we live in. I assume most people here believe in the theory of evolution, and therefore their universe was changed by Charles Darwin. How do we explore today? Well, we can explore with robots, and we can take people, so to speak, with them. One lesson, though, here is one of my favorite images. It's not a real image, it's an artist's impression of the Cassini spacecraft during orbit injection at Saturn, burning the main engine as it came into orbit for the first time around Saturn in the year 2004, in fact, on June the 30th. For me, this was a big event because I was involved, and that long boom on one side has instruments I was responsible for. Equally well, for other Europeans present, it was also important there was a lander carried on Cassini, which eventually, sometime later, some 7 months later, would land on Titan, a true act of exploration. But the lesson I want you to learn from this particular event, if there'd been no Cassini, there would have been no Huygens. Cooperation delivers. Thank you very much as a European to the United States of America. I'm very grateful. It was very nice to have the Cassini project manager sitting in the audience there. How else do we do exploration? Well, here are some of the exploring missions that we have here in Europe ongoing at the moment. Rosetta, going eventually to comet Churyumov-Gerasimenko. Of course, a few weeks ago it flew past Steins, and there is more excitement to come before we finally go into orbit around Churyumov-Gerasimenko in years to come. But interestingly, Rosetta delivered more than cometary science. Rosetta delivered 2 babies, or I guess it's correct to call them babies, Mars Express and Venus Express. We slid in behind Rosetta our first European mission to Mars and our first European mission to Venus. For me, this was a very grand step. I would say that probably if we hadn't done it using much of the same technology we'd used for Rosetta, although one obvious thing from the pictures and a moment's thought about where the spacecraft go, Rosetta goes out to the orbit of Jupiter, Venus Express goes to the orbit of Venus. There's a very, very big difference in the heat flux there, and in the solar flux. And you can see that in the number of size of the solar panels. Sorry, I didn't mean to do that. The lesson to be learned is that you can do robotic exploration in a systematic way, but it's a question of what the system is. The system here was we were going to the comet, we wouldn't go to another comet, we went to Mars, and then third time we went to Venus. The spacecraft probably came in just about 1.2 billion euros total in cost, and I'm sure it would have been more like 1.6 if we'd built them all from scratch separately. There are also other ways to do exploring. Gaia is another mission, very important mission for us, that is actually going to explore the solar system, or rather, people who can tackle the enormous data, a pile, mountain, whatever you call it, from Gaia, will be able to explore the solar system. Gaia is designed to track 1 billion stars in our galaxy, the Milky Way. It's primarily thought of as an astrophysical mission. Nonsense. It will also allow those people who are prepared to work with the massive amounts of data we're going to bring home to pursue and identify and track 10,000 near-Earth objects in our solar system, and potential threats, of course, to Earth. What other missions do we have to come? We're looking now, we're in studies with some pretty exciting things. Marco Polo, we're studying with JAXA, the Japanese Space Agency, a sample return mission to an asteroid, to a primitive body, obviously linking to Rosetta scientifically, and there'll be a fight to the death, perhaps not to the death, but at least to a standoff between Tandem and Laplace over whether we go back to Saturn or to the Jovian system, to the Galilean moons of Jupiter in particular, and Titan and possibly Enceladus if we go back to Saturn. There'll be a fight coming up in the near future, and John and I will be part of that, I imagine. We have to make a decision early next year which one of these to pursue as the highest priority. So back to the outer solar system, back to primitive bodies. But then there's another mission, one that I've only recently taken over, ExoMars. That's what robotic exploration means for me. And I'm a director of science, the last director of science to follow Roger, and there will be no more, because I'm now the director of science and robotic exploration. And I want to think about exploration rather than science. You'll see that the solar system missions we've got are diverse. They're going to small bodies, they've been to the outer planets, in fact we've been to the moon. We're going to different places, partly because scientists have an enormous amount of curiosity, and there is always somewhere new to explore. However, we have a neighbor. We have two neighbors, in fact, the Moon and Mars. These we can explore in a different sense, in a sense closer to the way Captain Fitzroy was mapping the hydrography of the world's oceans. In a way, Mars and Moon are close to us, closely linked to our planet, and perhaps need systematic exploration. And I think, to give you some sense of how much exploration we've already done, when I was a child in 1954, I had a book, I assure you, which showed this picture of Mars. It's Schiaparelli's picture, which was by then nearly 80 years old, but it hadn't changed. And I assure you also, as a 9-year-old little boy, I learned there were canals on Mars, and you can see the straight lines there. This, of course, excited me, and in fact, I'm very grateful. My liking for Mars is probably based on this idea of the shipping going along the canals of Mars rather than what Mars really is. And I've never really gotten rid of that. But that is only 50-odd years ago, and frankly, we know that is not Mars. Mars Express is our European contribution to that, and of course I don't need to delimit the Russian and the American contributions to the exploration of Mars in the last 50 years. We've already visited the planet. It's also already turned out to be one of the most difficult planets to visit. The number of missions that have had difficulties at Mars is, as everybody knows, legion. Still, we have been there, we are there. This is actually the best I can do in showing a canal on Mars. It's, of course, from the high-resolution stereo camera, giving 3D images of Mars from the ESA Mars Express mission. It is a world all of its own, and it's a world that has a message for us down on Earth. And I think it merits true exploration, and that is not leaving it just to the scientists. The scientists have to go along, like Charles Darwin, but we have to systematically explore this world, and I'm afraid that requires a disciplined approach. We can't go off in every direction the way my science program has to go off in every direction, because the frontiers of science are so broad. So here is our little summary of our ExoMars mission as it now stands, either an Ariane 5 or a Proton. Proton is formally a backup at this point. A carrier descent module with a rover, with a payload, Pasteur payload primarily focused at astrobiology, and then a lander, the Humboldt payload. The names are chosen deliberately, Humboldt, of course, being a great geophysicist, which will focus more on the geophysics and the environment of Mars. These are the first European contributions down on the surface of Mars, and we'll be launching that in 2013. However, I believe we have to go beyond this, and I actually think it is sensible when you're exploring to have a goal. If you don't have a goal, you go off, like I do with my science program, in all different directions. I'm certainly not against that for science. I'm a scientist myself, and I found there is no cure. But if you're going to explore, you need to focus and really build step by step to the grand exploration. For me, as a robotic explorer, the grand achievement concerning Mars is to go to Mars and bring some of it back. Mars sample return. And I'm happy to say we're talking seriously to NASA, not just about Mars sample return, but how to get there in a systematic way. In fact, with a certain nostalgia, I say ExoMars is the last time, I hope, that we start a mission without deciding jointly across the world, but particularly since at the minute the #1 nation exploring Mars is the US, we want to work with the US in a systematic way to get us eventually to a human achievement, the return of samples from Mars. And that is, for me, the way, the difference between robotic exploration and science. It's focused, it goes step by step. Both of them are done for mankind. Both of them are done to expand knowledge, but they have to be done in a different way. I think at that point I should stop. Thank you.
Yes, we want to give you the opportunity to ask a few questions now. So if you have some clarification questions or any question on the ESA program so far, and we give you again at the end some opportunity to ask more. So any burning questions before we move on? And in the meantime, also, please, if you have filled some question form, address them to the co-moderator so that we can address them. So, any questions on David's talk? Yes, please. Go to a microphone and ask the question.
My name is Pekka Tanskanen. I come from Finland, and I have the great pleasure of having worked together with David at ESA for several years. I'd like to ask you, David, have you given up all the thoughts of starting the trip to Mars from the moon instead of hoisting all the things directly from the Earth?
That's an interesting idea, and I think if you're taking humans further into space, particularly if you're taking them as far as Mars, you really should consider the moon as a staging post. I think for robotics, I would not think of doing that. So I think that's the answer. I mean, please don't get me wrong. They've just put me in charge of robots because I am such an automaton. But I do like people, and I like astronauts too, but that's somebody else's responsibility. So, I mean, I think that's just, I certainly see, in fact, within the agency, we're moving towards thinking of the next lunar missions, again, taking in the idea that exploration must be focused. The next lunar missions should be thinking about, very much driven by the requirement of humans on the moon. I have to say, for robotic exploration of Mars, don't worry, we will be thinking about the idea of having humans on Mars, but it isn't going to drive the requirements the way I think it's appropriate concerning lunar exploration to say, hang the precise science, the most exciting science you want to do, let's look at what the requirements are to get habitability down on the surface of the moon. And so I think increasingly I would expect to see a focused lunar direction that is associated with human exploration.
So, thank you very much. We have to move on to the next talk, but you have the opportunity to ask further questions. So, now we have Dr. John Connolly from NASA's Johnson Space Center. He has worked on the Moon and Mars, or toward the Moon and Mars, for 20 years now, both in the human and the robotic exploration program. He's member of the Mars Phoenix science team, and is currently the chief designer for NASA's Altair lunar lander. So please welcome John Connolly.
Thank you. And I see from the graphic that was just posted, I've been given a field promotion. I indeed am not the head of planetary sciences for NASA. That is Jim Green, who was originally in your program. Jim asked me to step in for him today, having a conflict. He couldn't be here, and he sends his apologies. I was very honored, though, to be asked, because as Bernard mentioned, my particular specialty is usually associated with human exploration of the Moon and Mars. And I am one of those people, though, who believes that human exploration and robotic exploration go hand in hand. There's no such thing as science versus exploration, as some people try to make that differentiation. I believe that they are the same. You know, there is science that is accomplished by exploring the planets, be it with robots or with humans. So as I go through NASA's planetary science missions here in a few minutes, I want to bring to light how the missions to the planets with robots and how those with humans are inextricably linked. First of all, the cover slide here that Jim put together really describes NASA's philosophy for how we explore with robots mainly. It is that we fly by planets first, we then orbit them, we land on them, we rove on them, then we return samples from them, and those are planets or asteroids or comets. And then I would add to that, and then hopefully we send humans there. I think there's a very logical progression, and sometimes sample return, as in the case of the Moon, can be accomplished by humans. So let's move on here. One thing that struck me as we were putting these images together is that this is a very good time to be a planetary scientist. There are more missions flying to more destinations than probably any other time in history right now. And so much so that we had to divide this little presentation down into 3 sections. So this first one is planetary missions, but it does not include the moon and does not include Mars, because the number of missions going to those 2 destinations filled up a chart all by themselves. So truly, it's a good time to be a planetary scientist. So for our non-Mars, non-moon missions, we've shown you here graphically the missions that NASA is flying, and many of them that are joint efforts with ESA. As David mentioned, this is also a very good time for international cooperations in many missions. The Messenger mission is a week away from a flyby of Mercury, and you can see the flybys designated by the little triangles there, and it will go into orbit in 2011. ESA's Venus Express, David talked about that. NASA has an instrument called Aspera on that particular spacecraft. Epoxy Next I'll talk about in a little bit. Those are actually other missions that were repurposed as new missions. Turns out once you slam into a body with on a primary mission, you have a spacecraft that flies by, and you have a very good spacecraft that can go on and do other things. Dawn is another NASA mission that will orbit the asteroid Vespa for 150 days in 2011, and then it will depart Vespa and head on to Ceres for a 2015 encounter. Looking at some of the other ones, Juno is in development right now, looking at a 2011 launch and arrival at Jupiter in 2016. Cassini-Huygens continues to send us amazing images from, well, most recently from a close flyby of Enceladus. I work the Human Lunar Lander program for NASA, and my GN&C lead is the same GN&C lead that we borrowed from the Cassini mission. So I get a daily update about what Cassini is doing, and the guy I have working for me couldn't be more excited about close flybys of distant worlds. And outer planet flagships. We'll talk about those a little bit more. David mentioned them a little bit. These are some of the missions that are under consideration as joint ESA-NASA missions. And then finally, the Pluto Kuiper Belt mission. We have a 2015 flyby of Pluto. It will be very quick. Don't blink your eyes. And some encounters with some Kuiper Belt objects in 2018 and 2019. The Discovery program is NASA's small PI-led program. It's competitive. These missions go for about $500 million U.S. Each. The Stardust, most of them are already flying or have completed their missions. The Stardust mission in the middle row and the Deep Impact mission on the bottom, those are the ones that became the missions we call Next and Epoxy. And again, since the Stardust mission had returned its samples, since the Deep Impact mission had already impacted the comet, we had 2 very good basic spacecraft out there in space, and we were able to use them to try to recover some of the science that we lost from the Contour mission when it failed in 2002. The Grail mission, in the lower right, was just selected this year. It's a mission to study the lunar interior structure by mapping the gravitational mass variations of the moon, and hopefully that will be a complementary mission to a international lunar network that I'll talk about in a little bit. The New Frontiers program is NASA's big planetary mission program. These missions go for something on the order of $1 billion each. They are, again, PI-led, competitive, but they are more strategic in nature. The Pluto mission I talked about. The Juno mission is a Jupiter Polar Orbiter, as it says there, scheduled to launch in 2011. And we're just about to publish a draft announcement of opportunity for a 3rd New Frontiers mission. This again will be a billion-dollar class mission that addresses one of the 8 strategic targets that you see along the right side of this chart. So for the scientists out there who pay attention to these kind of things, stay tuned for that announcement of opportunity. Now looking ahead to lunar science. We've heard many papers this week about some of these missions. Chandrayaan, NASA has two instruments on the Chandrayaan mission. LRO and LCROSS are really the next NASA missions out on the launch pad, probably launching early in the spring. And of course, LCROSS is a South Pole permanently shadowed crater impactor, where we're going to try to kick up some material and measure what's in Shackleton crater at the South Pole of the Moon. And LRO is really our big human precursor mission to the Moon, where we're going to do mapping and various other kind of analysis of the lunar surface in order to help us pick landing sites for the eventual human missions that will follow in the next decade or so. That mission is going to go on for about a year and then be turned over to the science community after that point. After about a year of mapping, LRO will have the resolution of mapping that we need for planning the human missions, and at that point it becomes a science mission. I talked a little bit about GRAIL. LADEE is another one that's shown there. LADEE is the Lunar Atmosphere and Dust Environment Explorer. It will answer some of the questions about the tenuous lunar atmosphere and about the theorized interaction of the lunar dust and the lunar terminator. And that's scheduled to launch in 2011. And then finally, you see Artemis there. Well, Artemis is actually the Themis mission. We're again using spacecraft that have gone through their primary mission, and we're finding new uses for them. So 2 of the 5 Themis spacecraft will be moved to lunar orbit, where they'll look at the interaction of the solar wind with the Moon's magnetic field, and that'll provide us more data about the magnetic structure of the Moon and perhaps clues about what's going on inside. I wanted to talk just a little bit more about Lunar Reconnaissance Orbiter. I said I was going to make some connections between the human spaceflight program and the robotic spaceflight program. LRO is a prime example. When we put the LRO mission together, we had a combination of scientists and folks who represent NASA's Human Exploration program. And we sat down and we put together a list of what we thought the data was that we would want to collect on the Moon, not only to enable safe human landings, but to be able to scientifically select the most interesting sites to go to on the Moon. And as we selected the instruments, we kept in mind that once we have these maps of the Moon, that there's an opportunity for this mission to carry on and do world-class science. So LRO is a prime example of a spacecraft that is a perfect harmonious convergence of a spacecraft that's there to make human missions to the Moon safer by giving us data sets, as well as to create world-class science. The International Lunar Network is an interesting subject. We know very little about what's happening to the Moon just a meter or 2 below the surface. We really have no idea of the internal structure of the Moon other than a few pretty good guesses. And what you really need to do is you need to set up a seismic network in order to answer that question. The International Lunar Network is proposed as a collection of 6 to 8 landed vehicles, and that will form a collective geophysical network. The U.S. has committed to launch the first 4 of these nodes between 2013 and 2017, and we are now looking to the international community to supply the other 2 to 4 spacecraft to complete this network. We have defined a core set of seismic and heat flow instruments that will look at the lunar interior, but each network will likely have dedicated science that is unique to that mission. And we hope in the human exploration world to put some of our technology demonstrations and some other experiments on each of these landers as well. Now, then we have a lunar sample return mission planned. This is using proven technology. Humans seem to have worked back in the late 60s and early 70s. So when we get to about the end of the next decade, 2018 to the 2020 time frame, our plans right now are to restart human missions to the moon. And right now our baseline is that every human mission will bring back a minimum of 100 kilograms of samples, and we're actually looking at ways to increase that number to more like 250 or 400 kilograms of samples. So again, this is one of those places where science and exploration collide in a very good way. Finally, there's Mars missions. Mars Phoenix is in its extended mission mode right now. Spirit and Opportunity are waking up from a Mars winter. Opportunity is just beginning to roll out of Victoria Crater and undertake a very long trek to the large crater called Endeavour that's about 11 kilometers distant. Mars Express, David talked about. MRO continues to give us amazing imagery. Mars Science Laboratory is an interesting mission. I'll show you that because it's probably the biggest thing we've ever thrown at Mars. ExoMars, we look at partnering with ESA, and Mars Scouts. We just chose a mission called MAVEN, Mars Atmosphere and Volatile Evolution, for a Mars Scout mission in the 2013 launch window. 2019 is still to be determined what that will be. We have a rover shown there, but that is entirely for planning purposes. And then, of course, there's the holy grail of Mars science, Mars sample return, and we'll be working closely with the international community to define what that is. Okay, so I'm going to close with just two quick slides. One that shows the Mars Science Laboratory. I was just at JPL on the floor where this vehicle is being put together, and what I was stunned by was the connection here with potential human missions. Number one, the rover is the size of a Cooper Mini. It is big. And it looks rather well built too. I'm sure it can go off road just about anywhere. And then the heat shield that you see there is 4.5 meters in diameter. That's only half a meter smaller than the heat shield of our Orion human capsule that we're building to replace the space shuttle. So our planetary science missions, our robotic missions, are starting to become of the same scale as our human missions. So I think those are all coming together. And then finally, big missions done in an international way. We call those the outer planet flagships. David mentioned we have some studies underway. We have to down select to a number of to one to pursue sometime in the next year. And again, we're going after one of the big planets, either Europa and Jupiter, or Titan and its moons, or Saturn and its moons. So that's a quick update of what's going on for NASA, and I'll turn it over. Okay.
So, any first question on John's presentation? Please fill down the question form also for the general discussion. I don't see immediate response. And okay, so we move to the last presentation where as the convener of the Space Exploration Symposium here, we have seen that there is also a lot of activities outside what ESA and NASA are doing. And so thanks to the presenters from this, we have compiled a set of slides showing that what is happening elsewhere. So JAXA in particular has a quite ambitious space exploration program with lunar exploration on the suite of what they have done with E10, Kaguya, and a follow-up, and also a program of solar system exploration with both interest in primitive bodies, but also in terrestrial planets. You have seen the beautiful results obtained by Kaguya Selene that are addressing the issues of origin and evolution of the moon with a comprehensive set of measurements from their cameras, from their spectrometers. And also measurements that have been obtained by a number of sub-satellites that allowed for them to make some gravity map of the moon. So JAXA has also long-term lunar exploration strategy, and that is with the Selene follow-on, and we have heard about some of ongoing studies for this element. An example of this latest data products that Kaguya has delivered with the laser altimeter experiment. So with much progress in both the topography and also the gravity of the moon. From the Indian side, we were lucky to see a few of our ISRO colleagues, but many of them are at home, very busy to prepare for the launch of Chandrayaan-1, a very international mission that carries payloads. From 3 payloads are coming from ESA and some European institutes, but also from NASA and from Bulgaria. So it's a model of a scientific platform which has been developed in a very rigorous manner, but in a very short time frame, with payload on the platform and even a technology impactor that is instrumented. And our ISRO colleagues are also looking at next generation of missions with lunar orbiters, landers, rovers, and advanced instrumentation that will be on board. So clearly, there are very strong new players in the field of lunar and planetary missions. In China, also, we have seen some results from the Chang'e-1 mission with very good instruments and also a set of global survey of the moon with stereo images, with laser altimeter, with X-ray and gamma ray instrument. Even microwave sonder to measure the temperature of the moon. And our Chinese friends are looking toward the future. So Chang'e-1 also was done internationally, and ESA has contributed through the use of our ground station to double the amount of data. But for the future, our Chinese colleagues are looking at landers, sample return, as a preparation of future activities on the moon. There is also mentioned some ongoing Chinese-Russian cooperation on Mars mission, and where some scientific instruments have been identified that could be provided from the Chinese side. Now, also at this conference, we have learned about a very comprehensive set of missions, and Dr. Olga Satseva provided me some of this information, where we have the Phobos Grunt mission that is being prepared, and a series of other astronomical observatories, but also planetary missions that build on the concept of modules that are being developed, like it was done for the Lunar series, where you had some modules that were in orbit, others carrying rover or sample return. The same type of approach with some kits of modules that are being prepared for Phobos Grunt, or that can be reused in part, for instance, for a contribution to a lunar project, lunar globe. Also, countries like Canada, both very involved in preparing for mission to the moon and Mars, but with some instrument contribution, for instance, on Mars Phoenix, and you will hear about that tomorrow in the late breaking news, and also in MSL or in ExoMars, with use of technologies, robotic technologies, and also making use of beautiful sites that they have in Canada where they can provide some analogs for Mars. We got also very interesting presentation from our X-Prize crew, a newcomer in the area of lunar and planetary missions with the Google Lunar X-Prize that is inspiring a number of teams that are developing a concept of small landers and rovers. And following this prize inspiration, there is a variety of concepts that are being worked on. How can we work together? From the lunar side, we have been working for the last 14 years in the frame of the International Lunar Exploration Working Group to make this expert meet scientists, technologists, engineers, space agencies, but also reaching out to the public. And we are organizing every year a large conference. The next one will be organized jointly with the NASA League group and the Space Resource Roundtable in Port Canaveral on the last week of October. And I would really invite you to attend and contribute. And we are going to convey some of the lessons and some of the news that we have discovered here at Glasgow. ILUG in particular had established a kind of a generic roadmap where progressively starting with robotic precursor, going into a permanent robotic presence, a global robotic village on the moon, and placing larger infrastructures, we could prepare for human outposts and an international lunar base. We have even views from the young generation. Here we were quite impressed. We had a group of young professionals that worked on the design of missions returning samples from comets or returning samples from asteroids. And clearly there is a very strong interest in our youth to prepare for projects, to also to be part of the lunar and planetary mission we are preparing for the future. So I would like to stop here, and as the preparation for discussion, there are some themes that we can put on the table, but I expect that now you should end our questions, and please come to the microphone so that we can use the last 5 minutes to address and have a very lively discussion. So anything related to the science we can do with these missions, any facts, what technology we want to develop, how we prepare for the human missions. And I see a set of questions being handed to me. So please, if you have ask a question, go closer to the microphone and we'll have a discussion. Thank you. Okay, so is Mr. Jürgen Schlutz here? Can you go to the microphone and ask your question?
Well, there's two of them, so I'll just start with one. The first one going to David Southwood, as you have given a very thorough overview of what ESA is doing currently in exploration. But when I compare to the other nations, NASA, but also China, Japan, India, what was missing is basically the lunar exploration part of it. So I was wondering if you can elaborate a little more on what European activities in robotic exploration towards the moon are, and where, without trying to duplicate science objectives, obviously, of the partners.
Well, very quickly, we've already done Smart 1, and so we kind of led a flotilla back to the moon. Following that, we've been studying something called Moon Next, which is just a question of money, which will not be going forward. It's in phase B1 at this point, but it's been decided that it's not of sufficient high priority to go forward. And with Simonetta Di Pippo, who looks after human activities in space, we've decided that the next planning for the moon should be very much focused on human requirements at the moon. And so at the moment she is proposing a cargo lander to be done in cooperation with a return to the moon in a decade to come. So that is at present, I think, the best summation of the focus on the moon within ESA.
Okay, so I have another question here I could summarize. With growing interest in human flights, how far will technology demonstration be a primary driver for exploration rather than science? And I think we could address this question to both of you.
How much will technology be a driver rather than science? Again, I see those as complementary, not competing. Typically, we like to first test technologies out on missions where human lives will not be lost. And so, it's always good to test something brand new on a robotic mission. Not that robotic missions are expendable, but, a few $100 million in case something doesn't quite work right is a lot easier to swallow than a human mission. And again, I just see it as complementary. The reason we're sending human missions out into space is to do world-class science, to get scientists as close to the subject matter as possible. The technology is just a way to get there.
David?
Yeah, I'm not sure I entirely agree, but in that I feel, I mean, clearly technology is linked to science, and science gave us technology in the first place. But I actually think for exploration, you've got to look at the technology and you've got to say, where is it you want to go? What is it you're going to want to do? And that will set you technological goals. You may have to know the science to tell you what it is you require. The science sets the requirements. And once you've got there, exactly as you said, John, you bring back science. And one of the prime beneficiaries of exploration is science. But I actually think you've got to take the techno side of things very seriously, because there are inevitably all sorts of avenues we could explore in technology. We should focus on what it is we want to do and follow a technological path that way. Certainly that's the way we Europeans, perhaps on a slightly tighter budget than you, are thinking. But that may be just, a budgetary matter. But certainly that's the way I feel.
Is Rodney Buckland here near microphone? Oh, you want to go to microphone and ask your question? No, thank you.
John Connolly mentioned PI-led missions. I'm not sure exactly which ones they were, but David Southwood didn't. So is there any significant difference in your approach in terms of, let's say, mission management?
Yes, there is actually. We have PI-led missions in the Earth Explorers, in Earth observation. We don't have PI-led missions as such elsewhere in our program at all. We have PIs, but it's simply, for us, there's a frustrating number of Europeans, and if you like, we can't privilege individual. PI stands for privileged individual, as you probably know. And so, we have to do things collectively. I'm sorry, that's old Europe, I'm afraid. But no, there is a difference in approach in that I would love it if we, if you like, had the capacity to be as free-ranging as our American cousins and have this sort of scattering of PI-led missions supplementing a longer-term, larger-scale activity. But we Europeans do things a bit on the cheap, I'm afraid, and they, for me,
okay.
I would love to have them, but it's money.
Anybody on the microphone? I have a question from Nicola Soper from Astrium, but I think she's far from the microphone. I'll read the question. Do you foresee the winner of the X Prize Cup being incorporated into the International Lunar Network of missions? Maybe that's for Dave. So you see that the winner of the X Prize Cup, could they then deliver eventually some nodes for the ILN?
If the winner of the X Prize Cup could deliver one of the geophysical nodes, that would be wonderful. I don't think that's actually a criteria for winning the X Prize Cup. I think you just have to land and rove. Landing the geophysical network might be a bit beyond the scope of that mission. But if someone is interested in it, that would be wonderful.
But possibly the technology that will be demonstrated, or even the business model, could lead to development of a number of small lunar missions that will find you as a customer.
Well, I think the technology that would be demonstrated it would be a lander done by a private entity landing on the moon, and that's a big step. That would sort of eventually. I would like to get out of the business of landing payloads on the moon and just have someone else drop them off for me.
Yeah, it should be a very strong incentive to keep a good delivery schedule. And for this, okay, we have to launch on time, but we have also to close in time. And we have reached the end of this session, so we have celebrated today the Curien Prize, and I think when you think that there is a Curien station on Titan now, that gives a perspective. We have celebrated a number of results from ongoing missions, how through cooperation we can perform and deliver, and that there is a very strong future in lunar and planetary robotic missions, but also a duty for some of them to prepare for some of the human missions. And this is bridging to a panel that we will have tomorrow. We have organized in a coordinated way with IF. There will be a panel on the Moon and Mars, the next destination for human, tomorrow. So I would encourage you to attend that and to see how we bridge from this robotic mission towards human mission. Thank you very much.